Hello everyone, a very good morning. My name is Prashant. I welcome you all to AWS Architect Training by Edureka. Guys, can you quickly confirm if my voice is audible and is my screen visible to all of you? Guys, am I audible? Yes, fantastic. Couple of people already confirming. Great. So we will wait for another few minutes and then we'll start with our today's session. All right. Once again, a very good morning. My name is Prashant. I welcome you all to AWS Architect Training by Edureka. My dear friends, in our yesterday's session, we talked about Module 8, where we discussed about different application services like SES, SNS, SQS, SWF. And then we talked about Event Bridge and we talked about step functions, right? So today we'll move a bit forward. We'll talk about one small topic which is left from our module 8, that is your serverless computing. Now what exactly serverless computing is and how it works is what we'll try to understand. Also, and also we'll try to see demo around this serverless computing, right? So let's get started with this, and then after completing this part we'll start with our module 9. Okay, and as part of module 9 we'll discuss a couple of services, so as we progress we'll talk about that, but for now let's get started with our serverless computing, right? So without any further delay, I want to understand from all of you guys, what is computing? Yes, may I have quick response from all of you? What is computing according to all of you guys? Calculating, okay. Find the solution is that okay. Communicating. No, I'm talking about computing. Easy access. Okay. What is computing? Processing. Exactly. This was the answer which I was looking for. Computing is nothing but ability to process. Ability to process the data and give relevant outcome. Agree with me, everyone? Yes or no? It is nothing but processing. Right? You give the data, you process the data, and you get an outcome to it. That is what your computing is in a very simple terms. Now, let us understand the three layers of application, three-tier architecture of application. Ideally, your application has three tiers, right? You have something called as front end, you have something called as back end, and you have database. Is everyone aware of this? Your application has three-tier architecture: front end, application logic, and your database. Any application you take, these three layers are must. Front end is nothing but what you see on your screen. Front end is what you see on your browsers, right? That is your UI. That is your front end. Back end is your application logic. If you click on anything, it triggers your backend and displays you an outcome. That is your backend. That is your backend. Database is where your application data is stored. Guys, are you all along with me understanding this part? Yes or no? I would appreciate if everyone can be quick to confirm. Thank you. Thank you for that quick confirmation. So now, I want to understand from you guys. In our on-premises, ideally, what happens is we have one server for front end, we have another server for our application logic, and we have one database, right? So for managing one application, can I am having three different resources. For one application, I'm having three different resources. One server for your front end, other one for your back end, another one for your database. Now this is a standalone setup. If I want high availability, minimum I should have 6 resources, and if my application is expecting high amount of load, then it can go somewhere around 10 to 12 resources just for one single application, right? So help me understand, my dear friends. In this 3-tier architecture, forget your database for a moment. We're not discussing database right now. In this 3-tier architecture, help me understand which layer is always active and running. In this 3-tier architecture, which layer is always, forget database, between front end and back end, just tell me which layer is always active and running. Everyone, I would like to seek everyone's response on this. Okay. Couple of people say both, couple of people say back end, couple of people say front end, and still couple of people are saying DB. So as I said, please forget database. We are not discussing database right now. Between your front end and your back end, tell me which layer is always active and running. Okay. Looks like majority says it is back end. Okay. So let me tell you. Okay, let me ask one more other question, then we'll answer this. We'll discuss this. Okay. If you were in on-premise infrastructure, let's assume that you're having your infrastructure in on-premises, and you are supposed to factor a new server. So you're supposed to decide some specifications. So which layer would you take into consideration to decide the specifications of your machine? You're supposed to finalize or factor a server, right? And for that server, you're supposed to finalize some specification. So which layer would you take into consideration to confirm the specifications of your machine, front end or your back end? Everyone, let's be quick. Again, couple of people are both, couple of people say backend. Okay. All right. All right. So let's now understand answer to this question. The first question was, which layer is always active and running? So to answer this question, the answer is front end is always active and running. Front end is always active and running. Backend is not always active and running. Backend has to be triggered. Now, for example, you might tell me, Prashant, no, I don't agree. Before you start discussing that way, let me show you an example here. Can I say this is my front end? Yes or no? Everyone. Can I say this is my front end? Now, this front end is available to me whenever I log in. This front end is available to me whenever I log in. Now, if you say me that your backend is always active and running, then what is the need for me to click on EC2 here? What is the need for me to click on instances? What is the need for me to click on launch instances? And only then instances gets launched. Because if backend is always active and running, then there is no need for me to click on all of this. It should ideally perform this job without me interrupting. Agree with me on this. If I am clicking on one of the option, that means I am triggering that respective backend. So the moment I trigger, that backend logic becomes active. It does the job specified, and then again it becomes inactive. Do you all agree now that your backend is not always active and running? It's your front end which is always active and running. Yes or no? If I'm clicking on this, it is at the backend triggering you, and it is triggering your backend. So once backend gets triggered, it will perform the task which is specified. If this click is made, it is specified with certain task. It will perform the task, and again it becomes inactive till the next click. Do you all agree? Anyone who still has any doubts on this? By seeing the console, we can say backend active or not. Not by seeing the console, not by seeing your server console, anything. The moment you make any click, you're activating your backend. The logic is that simple. You're doing anything, you're basically, your click is getting as an input. That input is getting processed, and it is showing us the next outcome. Now I gave click, it took as an input. If I click on this, so this will act as an input, and once this input is done, it will process and give me an outcome. Am I making sense, everyone? Are we all on the same page? So your backend is not always active and running. It works on the basis of trigger. Please be informed. Your backend works on the basis of trigger. Are we clear? Okay, someone asked if your backend is down, then obviously nothing you can do on your front end. So I agree. I agree to that. If your backend, your logic server is down, nothing you can do on your front end. That is very true. But my question was, which is always active and running? I never said your backend is up or down. So even I'm telling your backend is still up, but it is not running. There is a difference between being up and being running, being in a running state. Agree with me? Your server is up, but is the logic running there? No. Logic is not running by default. Logic has to be triggered. Is it doing some processing? No. It has to be initiated. Now I'll make your understanding more clear by giving one more example here. If you say your backend server is always active and running, Then help me understand when your business, during your business peak hours, why is the CPU utilization increasing, and why does this CPU utilization come down during off business hour? You must have noticed during your peak business hour the CPU utilization increases like anything, and during your off business hours the CPU utilization comes down. If your backend server was always active and running, then the CPU should be constant. It should not increase and decrease. Agree with me? If CPU is increasing and decreasing, that means during your peak business hours, many people are using so much amount of processing it has to do. And since it is doing a good amount of processing, the CPU utilization increases. And during your off business hours, the processing done is reduced. And since that processing done is reduced, the CPU utilization comes down, which also definitely signifies that your backend, your application logic is not always active and running. Are we all on the same page? Everyone? I hope now everyone is pretty clear which is always active and running and which is not. Cool. Now let's move a bit forward. The second question. Which one would you use to define the specifications of your machine? It is always your backend. Because your front end is gonna remain the same, but your backend is gonna increase. The processing is gonna require a load, right? Because when there are 10 users connected, the front end is same. When there are 10,000 users connected, still the front end is same. And when there are 10 million users connected, and still the front end is same. So your front end is not going to increase or decrease with the number of usage. The size of your front end is going to remain the same. But that is not the case with your back end. When there are 10 users connected, the amount of processing done is minimal. When there are 10,000, the amount of processing increases. And when there are 10 million, obviously it has a lot of thing to process. Agree with me? So far we understood the three-layer architecture of an application, that is your front end, back end, and your database. We understood that your backend is not always active and running. It has to be triggered. We understood that the sizing of your machine is always defined on the basis of backend, not on the basis of front end. Right? This is what we have discussed so far. Now moving on to the next part. Which is what is serverless computing? Because having understood what is your front end, what is your back end, now it is important that you understand what is serverless computing. Ideally, in our on-premise infrastructure, for your back end you have one server, for your front end you have one server. Now help me understand one thing, my dear friends. Let's assume that I'm in a stock exchange business. I know my business is Monday through Friday. No business on Saturdays and Sundays. Still, can I say I'll have to manage the dedicated server, the backend server? Because when there is no load on Saturdays and Sundays, that means there is nothing to process on that server on Saturdays and Sundays. Agree with me? But still, even when the backend server is idle, can I say I'll have to pay for it? Obviously, yes. This is one thing. You are paying for your idle time also. When there is no processing being done on your backend server, still you're paying for it. Second, since this is a backend server, still can I say you'll have to manage, maintain your infrastructure like operating system upgrade and all of that. The resource management is still under your responsibility. right? The resource management is still your overhead and responsibility, correct? So what AWS says, when you have resource which is being idle, okay, why do you want to pay for it? Second, why do you want to take overhead of managing your backend server? Let that be managed by us. Let the underlying infrastructure be managed by us. You as an organization just focus on your application code, nothing else. So let's understand more about serverless computing. So serverless computing allows you to build and run application without worrying about underlying server. It is taken care by AWS because the server on which your application is running is fully managed, provisioned and scaled by AWS. So you as an organization, you will not have any server to manage for your backend. You don't have to worry about the scalability. You never pay for the idle time. It is highly available and it has built-in fault tolerance and less components to manage. That is what we call it as serverless computing. So you can have your front end anywhere, but your backend can be serverless, right? So backend here on AWS, there is a service called as AWS Lambda. So AWS Lambda is a serverless computing platform where you can run code for any type of backend service in response to some kind of events. Events are nothing but your triggers, right? So compute service will run attributes without managing the underlying server, and it is event driven. There should be some event for it to get triggered, right? So let us understand how it works. So before I start explaining this, I'll quickly put a demonstration of what we are going to do so that all of you will have a pretty clear understanding. Allow me one moment, okay? So let's assume that I'm an organization xyz.com. Let's assume that I'm an organization xyz.com. I have my portal called xyz.com/upload. I have this particular portal of mine called as xyz.com/upload. Onto this portal, I want my users to upload their monthly internet bill, telephone bills, mobile bills for the purpose of reimbursement. Okay. So here user opens the portal, says xyz.com/upload, uploads the bill. And I've designed my application in such a way that moment user uploads a bill on this portal, it should directly get uploaded on S3 rather than storing it locally on the server. Upload it on S3, right? That's how I have designed this application. So the moment user says upload, the file gets uploaded on the S3. The file gets uploaded on S3. Now I want to do processing of it, right? That we will discuss later. So the moment the file gets uploaded, it will trigger my AWS Lambda. That is my backend service, my application logic. It will trigger my AWS Lambda. The moment Lambda is getting triggered, it will fetch the detail of the files. Okay. It will connect with S3, fetch the details of the file, and then use those details and trigger my SES, the simple email service, to give an confirmation to user, that hey, we have received your file with so and so file name. We shall get back to you after processing something like that. So can I say this is my backend task? Yes or no? Everyone. Can I say this is my backend task where user uploads a file and user should receive a confirmation on file being received. So using SES service, I want to send this confirmation. Okay. Using this SES, I want to send this confirmation. So here I use my Lambda service. Lambda service will perform the backend task of getting the details of the file. Lambda service will get the details of the file, perform content personalization, and send an email using SES service. We can directly send an SES from S3, but understand it will not allow you to do content personalization. Here I want to perform some content personalization. I hope I'm making sense. The backend task which I have factored here is Lambda will get the details of the file. After getting the details of the file, it will use those details and trigger SES service and send an user an email telling that thank you for uploading your file with a file name. We have received it. We shall process. We'll get back to you. Some kind of personal messages, right? So in Lambda, if you want to do further processing, you can define that also in your code. What info will Lambda give back to S3? There is no info that Lambda has to give to S3. S3 will invoke Lambda. Lambda will go to S3, get the details of the file. What file is uploaded, it will get the detail, use those details and trigger your SES. Guys, are we all clear with the part of demonstration? What is SES? SES is nothing but your simple email service which we discussed yesterday. Is everyone clear? Can I get started with the demonstration? Thank you. So here I go. I go to my console here. So we'll first have to have an S3 configured. We'll have to have an S3 bucket configured. Between S3 and Lambda, there is nothing much. The moment there is a file uploaded on S3 bucket, it will trigger my AWS Lambda. My Lambda will get invoked. The moment Lambda is invoked, it will check with the S3 for the details of the file, use those details, trigger SES and send an email to the user. Are we clear? Edureka guest. Thank you. So now I click on this already existing bucket. Let us delete this. We'll use this existing bucket itself because I need an S3 bucket, nothing else. I'm just cleaning the, dashboard. We'll use this existing bucket itself and we'll perform the processing, right? So I have my S3 bucket already available. Next, I want to configure SES. That is your simple email service. So here, I need someone to quickly help me with that email address. Any one person. Quickly help me with your email address. And you should have access to your mailbox right now. Okay, I got it. So Vittal, you have access to your mailbox. You can log into your mailbox, right? All right, so I have added. This is the first I received, so I have added that. Now it says pending verification. Allow me one moment. Let me log into my Gmail. Vittal, I would request you to please log into your mailbox as well. So I have logged into my mailbox. I have logged into my mailbox. And here, if you notice, I received an email from AWS, email address verification request. So now I'll click on this and it should say, congratulations, you have verified your email address, right? Congratulations, you have verified your email address. Done. So come back here. So my verification is done. Even Vittal has verified. So both the email addresses are now verified. Okay. We'll use this SES later. Let's come back to the next part of discussion here. That is your Lambda. Now Lambda is meant for your backend. Normally for your backend server, right? If for you to run your backend, you require a server. On that server, you require an operating system. On that operating system, you want some middleware runtime libraries. And then on top of that, you deploy your code. Is that correct? Yes or no? You require a server. On that server, you require an operating system. On that operating system, you require some middleware. On that middleware, you require some runtime libraries and all of that. On top of this, you run your code. So can I say, right from operating system up to your application, everything will become your responsibility if you go with this model? Agree, everyone? If any of this layer has any issue, if operating system has an issue, if middleware has an issue, if runtime library has an issue, then it is all your overhead. Too many components to manage and maintain. So here with AWS Lambda service, pay attention. With AWS Lambda service, you directly say create function. Give a name to your function. Okay. Give a name to your function and it will ask you to define which runtime you want. Your application code is compatible with which runtime? Is it .NET, Go1, Java, Node.js, Python, Ruby? You define that. You define that. So right now mine is with Node.js 10x. So I want that as my runtime. Then it will ask for, IAM role. So I have one of the IAM role already created. I'm just associating that and I'll say create function. Now pay attention, I have defined which runtime I want to use, nothing else so far. I did not create any server, anything. I just defined which runtime I want. I want Node.js 10x. This is what I have defined, right? So here for me to run my application, I don't need any server at all. I don't need any server at all. I can directly I can specify my application code, my backend logical code. Pay attention. So as a developer, I have my code here, right? So you will notice how I specify this code and how we use it. Okay. So this is my code. Come back here. I directly upload my code here itself. Okay. I directly upload my code here. And I'll say deploy. That's it. I have not managed any server, nothing. I directly deployed my code. So far, no server created, no operating system, no runtime, no middleware, nothing is my overhead. I decided that my code is in Node.js 10x and I uploaded my code in Node.js. Now next, what will trigger this code? What will trigger this lambda? Everyone, from the diagram which we were talking, what is supposed to trigger this lambda? Yes, an upload to my S3 bucket. Yes or no? Any confusion? If there is a file uploaded in S3 bucket, it will trigger my lambda. Everyone on the same page? Kind of surprised to see different answers coming from users. Everyone, those who said different answers. Remember, I told you if there is any new file uploaded to this S3 bucket, it will trigger my AWS Lambda, and then Lambda indeed will fetch the details of the file and trigger SCS and send user an email. Correct? Any confusions on this? So trigger is definitely an file uploaded in my S3. Correct? So I say add a trigger. Now trigger can be from different data sources. It can be from API gateway. It can be IoT, Alexa, Apache Kafka, your load balancer, CloudWatch logs, code commit, Cognito, DynamoDB, Event Bridge, Kinesis, so many options. Right now ours is S3. So I say on this particular bucket, if there is any object created or added, right, then trigger my AWS Lambda. Trigger AWS Lambda. Clear? So we have done that. Now let me quickly duplicate this window. So far no server, nothing created. So now let's say I go to that particular S3 bucket. Okay. I upload a file onto this S3 bucket. The moment I upload, it will trigger my Lambda. So let's say this sample.var file. And I say upload. So upload is done. It has triggered my Lambda. And I have received an email. And this email is from mail to vittal@gmail.com via Amazon SCS. Demo file uploaded on S3. Thanks for uploading the file. We have received your file with the file name sample.var. Guys, am I making sense? This is the name of the file which I had uploaded. So can I say Lambda has fetched the name of the file and triggered my SCS service, used Vittal's email address, and it has sent an email to me? Yes. Everyone? So this is your backend task. Agree with me? Right now what we have done is a backend task. So for any kind of backend task, you can leverage your AWS Lambda. For any kind of backend task, you can leverage your AWS Lambda. Right? Let's say I'm uploading another file. So I received another code, other confirmation that, hey, we have received your file with this name. Do we see logs? Which logs? Whether the Lambda is triggered or not, is that the logs? Yes. You can see those details. You can see all those details regarding how many times this Lambda got triggered, what logs you want. All the details are available here. Here it is. So, at what time it was triggered. Right? Recent invocation details. And if you want to check some traces, If there are any errors or something, you can get notified. Right now, in our case, we don't have anything of that sort. But yeah, if you want, you can always review. Why it has used Vittal's email address? Because I have defined that in my code. Use source as this. Use source email address as this and send it to this user. So here, if you read this code is basically the moment it gets invoked, it will get the details from S3, right? It checks with S3 for the object details. Once it gets that detail, it will invoke AWS SES and it will send this message, and that here it will include the name of the file. Okay, it will include that name of the file and send it to the user, which is defined in to address. Okay, and here the subject line demo file uploaded. So all of this you can define in your code. All of this you can define in your code. Am I making sense, everyone? Can we parse with file with lambda? So when you say parse, you mean you want to normalize, you want to do some kind of processing on that. Is that the requirement, Venkata? Yes, very much possible. Define your lambda code accordingly and you can do that kind of processing. The code has to be defined in such a way. CSV, that's what I'm telling. CSV file with email address, any different kind of processing which you want to do, right? Define your code accordingly and you will be able to do. Because lambda is going to do whatever you have defined in the code. So in the code, I have defined a very simple thing. So it has executed that. That simple as it is. Any doubts? Anyone? The requirements are obviously written by your developers, your coder. That is true. Okay, someone Edureka guest says, I have a doubt. Please shoot your question. Please don't wait for me to check with you. You have added a mail ID in SCS. Yes, I did. So what about that? I have added a mail ID in SCS and you defined a mail ID in the code also. So I have added that mail ID in SCS to verify. I need consent that I can use this email address to send emails. And that is what happens when you click on this URL. It says, pay attention. You have successfully verified an email address and you can start sending email from this address. So I wanted that consent. That is why I have added. That is why I have added this code. Am I making sense? By adding an SCS, I have given a consent, and by defining in a code, I am using that email address. Clear now? Is everyone clear on what AWS Lambda is and how it works? Can I move forward? So that was the pending part from our module 8 and I hope we are now clear. Lambda is not for free. It comes with a cost. We'll discuss on how it is charging you. Don't worry. It is not for free. So that was about your AWS Lambda. So now moving a bit forward, but before I move forward, Vittal, pay attention. Your email address which I had added, I am removing that. For the purpose of privacy, your security aspects are completely taken care. I removed your email address. I've already deleted that SCS. Okay. Just want to keep you informed. So cool. That was your AWS Lambda. So as I said, upload your code to Lambda, set up trigger. Lambda runs your code. When triggered, use only compute resource needed, and you pay as you go model, right? So here you get billed for every 100 millisecond the code executes, not for the code is residing, but that 100 milliseconds when the code gets executed, you only pay for that, and number of times the code gets triggered. Are we clear how the billing happens here? The time taken to execute the task which is defined in the code, and number of times that code is executed. So these are parameters on basis of which the billing happens. Manoj, is that answering your question? So you can have different data source for the purpose of trigger. It can be S3, RDS, DynamoDB, Kinesis, CloudFormation, CloudWatch, CodeCommit, SES, SNS, CloudFront, API, Gateway, IoT. So we already talked about these are the options which can be used to trigger your Lambda. So use case for data processing, for building your serverless backend, file processing, serverless website, data analytics, right? So next is your serverless application model. So this is kind of giving you an environment where without having any server, you can develop your application code. You can develop your application, right? It has its own CLI, it has its own template specification, right? Using that, you can develop your application without having a need for any server. For your front end also, it can be serverless. For your backend also, it can be serverless, right? So for backend, it can use Lambda. For front end, it has its own infrastructure, which is called a serverless application model, and it has its own CLI and language, right? So the syntax and everything are different for this. So you use this SAM, where you use the CLI commands and all of that specified, which are compatible with this SAM interface, and you develop your application. So you'll have one single deployment configuration window. You do debugging and testing of your application locally on the SAM itself, and you can integrate with various AWS development tools. For the purpose of backend, you can integrate with your AWS Lambda. SAM also allows you to use built-in best practices, and it can use your CloudFormation to deploy your required infrastructure. What is CloudFormation we'll eventually discuss, right? But just on a high level, SAM is nothing but completely serverless application model, kind of giving you an environment where you can develop your front end, back end of your application without having to have a dedicated server. Are we all clear? Everyone, I would need everyone to give me a one quick acknowledgement, because with this we complete our module 8. Step function we had already discussed in our yesterday's session. Okay. CloudWatch we have not yet covered. Okay. Any which ways, let me talk about CloudWatch, because though it is not there into curriculum, let me tell you, CloudWatch is not there as a part of your course curriculum. Okay. But since repeated request, so I'll quickly talk about CloudWatch and then we'll start with our module 9. Okay. So CloudWatch, understand in a very simple term, it is nothing but a service from AWS to monitor different AWS services under one single dashboard. Before I start with my module 9, quickly discussing about CloudWatch topic. Okay. So CloudWatch is basically a service from AWS for the purpose of monitoring. For the purpose of monitoring your AWS infrastructure, right? You have different servers, you have different databases, you have storage and all of that. So monitoring each of these elements might become very difficult for you. Monitoring each of these element might become difficult for you if you have to go back and check, hey, is all are all my instances running normally? Are all my resources running normally? Are they functioning normally? Right? So monitoring all of them one by one might become very difficult. So CloudWatch basically gives you a centralized dashboard where different AWS services can be monitored on one single dashboard or single console, right? So here you can, if you have an alarm associated, if you have alarm associated with your resources, so here in CloudWatch dashboard for all your hundreds and hundreds of resources, right? Okay, you have one single dashboard and you can monitor all of them on one single dashboard. Let it be your server, let it be your database, let it be your storage, let it be your network, any of these AWS services, any of these AWS services, you can monitor under one single window. That is what your CloudWatch is. It will give you an ability to define your own dashboard. In a very simple language, it is giving you an ability to define your own dashboard, right? So with this, you can also create your own personalized dashboard. You say create dashboard and give a name to it. Let's call it as demo. It allows you, it not only lets you that, you should use only the default dashboard. I can use my own personalized dashboard. So let's say, I'm selecting this pie chart as a representation of my dashboard, and it will ask me which metric would you want to monitor. So let's say I'm selecting metrics and I want to monitor certain metrics of any services like this. Let's say I want to monitor S3 for now, storage metrics, right? So number of objects is what I want to monitor in my buckets. Let's say I have this bucket called bucket size demo. Let's copy this name. So I want to monitor number of objects and bucket size. Let's say these are two elements which I want to monitor. So I say create widget. Like this, in a single dashboard, I can have multiple services also put up. Okay. In this single, I can have multiple dashboards being put up. And let me also legend type I'll save dashboard. So this is my dashboard. So right now it does not have enough information. So once it has enough information, right, it is gonna right now, just because we have created it, it is yet to get all the details. So once it has all the information, you'll be able to see them in this particular dashboard. You'll be able to see those details in this particular dashboard. So on the same, if I want to edit a bit, give me 1 second. So it is going to fetch all the details from our bucket, and it is going to show us how many resources are there, what is the total size, and all those information. So right now it has no data. Okay, but once it has enough data, you'll be able to see those information on this dashboard, because the size is very minimal, so it does not recognize that small size. Maybe if I upload some bigger size file, give me 1 second. Let me upload this file. So we should be seeing some input coming in very soon. So basically, this is how you create your own dashboard. So once this dashboard has enough data, it will get populated here, and you will be able to see in one single dashboard. You'll be able to see in one single dashboard. So I can say whether I want minimum, maximum, what kind of data I want to review, or I can say total, sum. I can have all those parameters defined, right? I can have all those elements or parameters defined here, and accordingly it will show us some outcomes. Guys, am I making sense? Everyone? So this way, for different services, for different AWS services, you can create your own personal dashboard. And it's not only this. Apart from that, you can also share your dashboard. You can also share your dashboard. I have a choice. I can share this dashboard publicly. Okay. So if I say start public sharing, then publicly all of you guys, even though you are not part of my AWS infrastructure, right? You will be able to see my dashboard. I'll show you. So this is the URL. I want you guys to quickly open that URL on your browser. You notice this kind of dashboard would come up. Right now it does not have enough data, so you're not seeing any input. But when it has data, you'll be able to see that as well. Guys, am I making sense? So I can publicly enable share of my dashboard, or if I want to restrict access, then that is also possible. I can say share dashboard with username and password. It requires the username and password. So here I should give my email address to which all users I want to allow and say confirm. So you will notice I'll receive an email for this. Now that I've enabled share with the password, So it will ask me for username and password. Okay. So I'm supposed to provide that username. So ideally, I should have received a password as well. Since my email was already registered, I'm not sure if it has not given me a password for that reason. Let me add it once again. So I'll show you what kind of, this is what a kind of email you should receive. Someone has shared a CloudWatch dashboard with you. You can find your temporary credential for accessing dashboard. This is kind of email which we should be receiving. Okay. So I'm not sure why this email has not come up yet, but this is what your CloudWatch console, when you say with password, it will give you your username and password. It will give you username and password. Because I had already registered, it could be, I would need to check if it is because of that it is not triggering me an email or something like that. Guys, am I making sense what your CloudWatch is and how it works, everyone? Can I have quick confirmation from all of you? Yes. Remember, your CloudWatch is nothing but a service to monitor your resources in one single dashboard. That's it. So you can create your own custom dashboard so that only your users have access to it. So number of usernames and password we can define, obviously, yes. With whom you want to share, you can define that. And they'll get an email like this. Okay. Can you repeat that part alone? I just deleted my dashboard. How do you want me to create again? So you say shared dashboard, and here it is. Said it. Like whosever email address you want to specify, you can define that here. prashant@xyz.com. So automatically that user will be added, and that user will receive an email with the username and password. Are we clear now? Yes. Everyone? Are we clear? Can I move forward? All right. All right. So now moving a bit forward. Now moving a bit forward, talking about the next part of discussion here. We will start with our module 9. We'll start with our module 9 and we'll try to understand what exactly your module 9 is all about and how it works, right? So allow me one moment here. Let me remove this dashboard. Clear? So that was about your CloudWatch, which was one pending part. So I remember there is one small topic from our module 3 called as storage gateway, which is pending. Okay. But apart from that, to best of my knowledge, all other topics are completed. Right. So storage gateway, we'll try to find some time and we'll try to discuss. But apart from that, can everyone confirm we are good? And guys, okay, someone said that Cloud Trail is pending. If you recall, we discussed about Cloud Trail in our module 2. Not sure if you are not aware, but in our module 2, when we were talking about, IAM, there I specifically showed you that you can track all your user events, like who has made what changes and all of that under our module 2. And that is part of your module 7. Actually, Cloud Trail is put up as a curriculum discussion. In our curriculum discussion, they are put up under module 7. But I remember discussing this in your module 2, where you can track which user has made what changes and all of that. Guys, do you recall? So Prasanna, in that case, I would request you to please go back, look into your module 2 class recording once again, because others are able to confirm that yes, we did discuss this. Okay. Because specifically people were asking doubts on this. Okay. So I had, instead of taking it in module 7, I discussed in module 2 itself. Okay. Bitika confirms that it was discussed on 18th. Okay. So 18th. Okay. So that is on 18th. So I'm not sure with the date, but as Bitika confirms that it was discussed on 18th. So I would request you to look into that specific recording, Prasanna. Are we clear? Can I move forward? Everyone? So now getting started with our module 9. Module 9 is all about your configuration management. So as part of your module 9, there are three major services which we will be discussing, which is your AWS Cloud Formation. Okay. We'll be talking about AWS OpsWork and Elastic Beanstalk. These are three services which we will be discussing as part of your module 9. Okay. So to start with AWS Cloud Formation, AWS Cloud Formation is a service from AWS which allows you to define code for your infrastructure. It is basically your infrastructure as a code. Okay. When I say infrastructure as a code, it might sound very different. That Prashant, are you telling that we develop some code to deploy our infrastructure? Yes, that is the intent. Like how for your application you write a code, and whenever you deploy that code, can I say you will get a similar kind of outcome? Yes or no? Everyone? Guys, can I have your quick confirmation? I have an application code, let's say index.html. So n number of times when I deploy that index.html, can I say it will give me same kind of outcome? Yes or no? I'm deploying that HTML code today, tomorrow, day after. even after 1 year, it will give me same outcome. Agree? Now help me understand, why is it giving me same outcome every time? Why is it giving me same outcome every time? Because the content is same, because the code is same, right? There is no change in the code. That is why it gives me same outcome every time. Agree with me? So understand one thing very clearly, that similarly, when you want to deploy similar kind of infrastructure over and over again and again, then you can leverage this cloud formation. Now, ideally, in what scenario would we use this? So the ideal scenario would be, a lot of time, if you understand, a lot of time, we need to test our application. And to test our application, we might want to rebuild similar kind of environment over and over again and again. Yes or no? Everyone, to test my application, like let's say this week I'm testing, I need to build that environment again. Again, next week when I'm doing same kind of testing, I need a similar kind of infrastructure again, right? So over the period of time, I want to have a similar kind of infrastructure. Then I can leverage on this particular service where my developers does not have to really depend on the infra team to get that infrastructure allocated. Okay. My developers does not have to every time, whenever they want this kind of infrastructure in our on-premises, what happen as a developer, whenever you want an infrastructure, certain infrastructure, you'll have to reach out to the infra team to, hey, can you please provide me this environment? There is always a heated argument between infra team and the developers team. Infra team says the developer did not give the request properly, and developers will always tell that infra team did not provide the required infrastructure or whatever we had asked for. Yes or no? I'm not telling anything out of box. So this is a common discussion in every organization. Agree with me on this? Infra team always has a complaint with the development team, and development team always has a complaint with the infra team that they don't understand our requirement, they don't provide the requirement clearly. All these kind of heated arguments, unnecessary arguments, right? Heated mail threads and exchanges. So with this cloud formation kind of service coming into picture, what is that you are able to enjoy is, as a developer, you need not every time be dependent on infra team. If you have certain requirement for certain kind of infrastructure, develop this kind of templates. Whenever you want the similar kind of infrastructure, just deploy that template and you're good to go. Your infrastructure would be ready. Now, this is what we call it as infrastructure as a code. This is what we call it as infrastructure as a code. So for your code, you write an executable template and you deploy those templates whenever you want that infrastructure. So infrastructure as a code is a type of IT setup where your DevOps team can automatically manage and provision infrastructure for application through a configuration file, which will include some code. It benefits DevOps team by allowing operations to evolve in the development process from the beginning, and developers to gain better understanding about supporting infrastructure. The configuration files, these configuration files can have your compute, database, storage, network, all of this can be defined in this code. It's not that only your servers you can deploy using this code. You can deploy your servers, you can deploy your storage, network, database, any AWS service for that case can be deployed using this codes. Okay. Any AWS services can be deployed using this code. So infrastructure as a code eliminates the manual drift, eliminates the manual drift through automation. Thereby, it will increase the speed and agility. So cloud formation is a service from AWS. Cloud formation is a service from AWS which allows you to perform this, define this infrastructure as a code, right? So this code has to be written in a JSON format or YML format. This code has to be written in your JSON or YML format. Now, how this code looks like, I'll show you a sample so that you'll have a better understanding, and then we'll discuss more in detail about it. Allow me one moment. So this is how your code has to be written in a JSON format. Okay, in a JSON format, or you can use this as well. So you have to write your codes in this format where you will have multiple elements of your template like format, version, description, parameters, right? Mapping. These are multiple sections or multiple elements in your template, right? Now, all are not mandatory, all are not optional. There are certain elements which are mandatory, certain elements which are optional. So depending on your requirement, you will be defining them clearly. Your resources section, your output section. So all this is are, elements of this template. So let's understand them one by one. Let's understand them one by one. So cloud formation is basically a service which helps the user in provisioning and configuring AWS resources via declarative template. The template has to be written in a JSON or YML format. It will help you automate and simplify the task of repeatedly creating group of related resources that will power your application. All the resources that you want to create can be defined in one single template, and that will be treated as one single stack. Stack are nothing but group of resources which you want to deploy in one single go. So you can define all of this, like in your same template, you can have configuration for your EC2, configuration for your RDS, configuration for your S3, configuration for your load balancer, configuration for your auto scaling, configuration for your VPC. All of that you can define in one single template. It will take care of the sequence of, deploying this template. You don't have to do anything. And this all in one single template, whatever you have defined, it will be treated as one single stack. Right? So stack is nothing but a collection of resources where you create, update, and delete that resources. Right? So talking more about the template part, as I was telling, you can write this template in either a JSON format or YML format. So while you define this template in JSON or YML format, there are certain elements of templates like your cloud format version, template format version, description, metadata, parameters, mapping, condition, transform, resource, output, right? So cloud format template format version is basically to give you a version control or to help you understand which version of template you're using. Description is a short note about the template so that anyone who is looking into this template does not have to break their head understanding what is the purpose of this template. Give a short note, short brief about your template so that quickly looking at the description, people get to understand, okay, this template will help me create an EC2 instance, or it will help me create so and so resources. Metadata are nothing but some additional information about your template, right? Parameters are nothing but your runtime value. Parameters are nothing but your runtime value. So here, if you notice, what do I mean when I say runtime value? Like the key pair that needs to be associated, the type of instance, whether T1, T2, T3, whatever, right? Your SSH location, the security group basically. So these are called as runtime values. So while you're creating your resources, these values are to be defined. So this is what you define under your parameter section. Mapping, if you have to understand, like in which region, which instance type, in which region, you can define that mapping. which instance type, which architecture to use, 64-bit architecture, which region, which AMI. So all of that is what you define under your mapping section. Guys, am I making sense so far? Everyone, am I making sense? Yes. Guys, can you be kind enough to confirm quickly? So you can also define conditions in your template. Like only if this condition passes, then cloud formation should create the resources. If the conditions are met, then let cloud formation create the resources. Apart from that, you can also define transform. Transform is mainly for your serverless application model. Okay. So to define your resources or resource creation, then in the resource section, you define the list of services that you want to create. And in output, what you want to return by the resources, what value do you want to show on the dashboard. So in all these elements, your resource is the only mandatory element. Rest are all optional element. You may define in your template, you may not define in your template. The choice is yours. The choice is yours. So now let us understand how to create. So I'll show you. Pay attention. Say cloud formation. I'll say create stack. So I have a choice. My template is ready, or I can use sample template. If template is ready, I can provide my S3 URL where my template is available, or I can upload a template from my local machine. So I'll upload my template from my local machine. Okay. So let's say I'm uploading this particular template, sample 24 CFN. Okay. I say next. Now these are the runtime values. Whatever is defined in the template, the same runtime will be applicable here. If you notice, in my runtime, in my parameter section, I set the default IP address as 182 something something. So that is why it has showed this value. Now, if while deploying this template, I can change if I want. By default, I defined a value in the template, but while deploying the template, I can change. So this is what your parameter section is all about. This is your parameters section is all about. Then I say next. Okay. Next, I can define something called as stack policy. Pay attention. I can define something called as stack policy. Now, what would I define under stack policy? Basically, here I would define who can make changes to this stack, who can delete something, who can add something, who can update something on this templates, or who can make some changes to this template, right? I can define that. And also I can define something called as delete policy. We have something called as deletion policy. So I can define that as well under this stack policy. Am I making sense? We'll talk about what is your deletion policy in some time from now. But am I making sense? So under your stack policy, you can define deletion policy, as well as you can define who can make changes to this template, who can update, who can, what all resources can be updated. All of those details you can define here. Basically, kind of giving a restriction on the changes that can be implemented on this cloud formation stack. Are we clear? Again, this also has to be written in a JSON format. Okay. This stack policy has to be written in a JSON format. Only one or two people responding, others. So if you don't have anything to specify, then you can leave it and you can say next. Now pay attention here. I'm gonna create this stack. The moment I say create stack, I want to take you to EC2 dashboard. You will notice an EC2 instance is getting created. Very soon, an EC2 instance is getting created. Pay attention. AE4E3, right? Do you notice this? So without I having to log into my EC2 console, just by deploying this template, I can have my resources created. Isn't it amazing? Like as a developer, I need not even depend on my the infra team anymore. If I can write this kind of template once or twice, whenever I want a similar kind of resources, I just deploy that template. Or for the same application, if I want to update, let's say earlier there were one server, now I want few additional server, I want to add some database, I want to add some storage and all of that, I can update this existing stack itself. We'll talk about, I can update this existing template also. Am I making sense? Everyone? I need not even create, a new stack. If it is for the same application, I want to have a same kind of infrastructure or some additional inputs, then I can update this existing template. I can add additional parameters here and it will create those relevant resources. It will create those relevant resources. Now, for example, here they have showed a template for your S3. Okay, they have showed a element for your S3. So if I want, I can just write this piece of code on this template itself. I can write this S3 bucket piece of code in this template under the resource section. Under this resource section. So pay attention here. So S3 bucket. So I can write something like this. I can give a name of the bucket. 1, 2, 3 closures. Am I making sense? What if the bucket already exists? It will throw an error. If the bucket with the same name already exists, it is very obvious it will throw you an error. This will work only if it is not existing. You can give this kind of references also, demo, dollar, date, time. Yeah, you can create in that aspect also, that format as well. That is very much allowed. Right? So you can make this kind of changes in the template, come back here, okay, on your cloud formation dashboard, say update. So you can use current template or you can replace current template. The choice is always yours. If I say use current template, it will ask you what you want to change. What is that specifically you want to change? Or you can replace the current template. Okay. Let's say you have made some changes. You can upload this template, newer template which you have, and you can go back, and to verify if it is taking the impact or not, you can view in designer also. So designer will actually give you a diagrammatic representation of what is getting created. Okay. So you can view in designer format also. The designer is not in scope of discussion for this course, so not going in detail, but there is an option you can discuss in, you can view this entire thing in designer aspect also. So I'll show you that also. Allow me a few minutes. So I say next. Okay. So there is an error in the template. So it is not allowing me to move to the next step. If you notice, there is some error in the template. So I think this should be removed. Allow me 1 second. Oh, looks like something, still an error. Not exception, comma, something on line number 194. Column 16. So there are multiple errors, maybe 1 second. One second. So this is the code. I can validate my template. Template is valid here. So let me take this code here. Come back. Say upload your file once again. Cool. So now I have added an S3 bucket. So we'll notice an S3 bucket also getting created. Okay. So now I'm updating my template. Pay attention. While updating, there are two ways of update. One, I can directly say update stack, or I can view what is getting changed. I can view on what is getting changed. Here it says an S3 bucket is getting added. So it will give you a JSON input, what is getting changed. So this is getting changed. This is getting changed. So in a change set, it gives you an opportunity to preview what changes are there from the previous template to this template. So it is kind of, I'm doing an incremental update. Guys, am I making sense, everyone? Yes, no? Can I have quick confirmation? Earlier I had a template deployed already. Now I am adding, now on this template I am adding some changes, right? So the changes is to add an additional S3 bucket. The changes is to add an additional S3 bucket in my existing template itself, right? So what I have done is, I updated a new template. And when I update this template, I have an option like how I would want to go ahead with the update. Whether I want to, replace the current template. If yes, replace current template and upload a new template. So I had replaced my current template and I am uploading a new template. While I'm uploading, I have this option to preview the change by using change set process. So it is telling me what is getting changed. Guys, am I making sense now? Prasanna, any specific doubt? You said no, just want to understand any specific doubt. So update is nothing but over the period of time. Okay. Update is nothing but over the period of time. If I'm upgrading my infrastructure, if I want to add some additional resources, I want to delete some resources, right? Then I need not create a new stack altogether. On the existing stack itself, I can upload a new version of template and get my resources created. Are we clear? That can be done by other services. I agree with your point, but you have to log into different dashboard, do all of this job manually. So cloud formation, as I was telling from last 10 minutes, 15 minutes, that cloud formation is a service which will allow you to create this kind of templates. So whenever you have a similar kind of requirement, you deploy this template. You need not go back doing one by one configuration. Deploy this configuration in one single go, all your resources would be created. That is the use of your cloud formation. I hope I'm making sense. The use of your cloud formation, you can do all of this job manually by logging to that specific, like you want a S3 bucket, say S3 bucket, and you can create on S3 console. You want an EC2 instance, you go to your EC2 console and get an EC2 instance created. You want an RDS, click on RDS and you can get your RDS created. But instead of doing this job by logging into one console, right, and wasting your time, you create this kind of template. Whenever you want this kind of resources to be created over and over again and again, rather than logging into every console, doing this job manually every time, deploy this one single template and you're good to go. Are we all clear? Everyone? So now you notice I have updated my template. It is not going to create a new instance. It is not going to create any new instance because the instance was already existing, but rather it will create a new S3 bucket. Notice this. This is the name of the bucket which I had given. Demo 2906 2021 S3, something like this. So someone asking me, can we do incremental update? Is that question answered? I'm not sure. I saw some question like that. Not sure whose question was that. Okay, it was yours, Prasanna, right? So incremental update. So are we clear how to update your cloud formation stack, everyone? So this is the S3 bucket creator. Is it support to revert any issues present? You mean the rollback part, Pavan Kumar? Will it support any rollback if we have any issues? Is that your question? Yes, it does support rollback also. It will support your rollback part as well. Don't worry. So, and also apart from this, it also allows you to create nested stack. Like this is one stack. This is one stack. Within this stack, I can have one more stack created. That is called as nested stack. That is called as nested stack. A stack within stack kind of setup can be created. Okay. So I'm right now in this stack and I can say create stack. Create stack with existing resources with new resources. So that would be a stack within stack kind of scenario. Like I can have one parent stack. Within parent stack, I want to create multiple child stack, right? So that is possible, something like this. You have one parent stack. Within that, I can create a child stack. Within that child stack, I can create one more child stack. So stack within stack scenario, where you can have some elements which are globally defined in parent stack. The same can be referenced in your child stack so that you don't have to redefine the same elements again and again in every template. Guys, am I making sense with this? Stack within stack is nothing but similar kind of elements you need not define in every template. You have one template, one element defined in globally. So you can call that in other templates also. That is your stack within stack scenario. So as we were talking about stack updates, so to make changes to a stack, right, or to change your resources, you can update the stack template instead of deleting it and creating a new stack. So I just showed you how you can update your stack, right? It compares what you submit and current template and updates only the changed resources. So that is your incremental part alone will be updated. Not is that, no, it is not that it will create from the scratch once again. It will only update what is changed. We saw that also. So we saw how to update. An update can happen in a different formats. Update with no interruption, update with some interruption, and replacement. Update with no interruption. Right now, which we did, can I say it was an update with no interruption? Your EC2 was functioning absolutely normal, and it has automatically created a new S3 bucket as a part of same stack. Agree with me? So that is your update with no interruption. Now there are some changes which you want to perform, and that changes require some downtime or all of that. So that will fall under update with some interruption. And then you have replacement. So replacement is nothing but when your physical stacks changes. Let's say currently this EC2 instance has a key name called Ganesh Prashant. Now I want to update. So I say use current template, but I want to change my key pair. I want to change my key pair. So for this, it will create a replacement. Replacement of EC2 instance alone. Replacement of EC2 instance alone. Last time we saw how to work with your change stack. This time we'll directly update. Okay. Now here, if you notice, what it will do is it will create a new EC2 instance first and then terminate this one. So it will create a replacement very soon. Notice this, it has created a new instance. So this is an example of your replacement setup. Okay, once this instance is up and running, it will terminate this instance. Guys, am I making sense? So we saw update with no interruption. We saw replacement also now. Okay. So depending on the kind of properties you are changing in the template, it will decide under which category your update will fall. Whether it is update with no interruption, update with some interruption, or replacement. So depending on what you're trying to update, it will decide the category of your update type, or it will decide your update behavior. It also allows you change set. So I showed you that as well. Like with change set, you can preview what is getting changed, and then you can decide whether you want to execute those changes or not. So stack policy, in the beginning itself, I was telling you, stack policy is kind of allowing you to define who can make any changes to stack, like who can update, who can, delete, who can modify. So all of that you can define under your stack policy. So we also talked along with stack policy, I was telling you that you can define something called as deletion policy. So deletion policy has three options. It allows you to delete stack, and when you delete stack, you can also delete the associated resources. This is one part of your delete policy. Delete stack, but retain the resource which are created using that stack. Delete the stack, but retain the resources. Like from this stack, I've created an EC2 instance, I've created an S3 bucket and all of that. So I can define a retain policy. When I define retain policy, please understand, it will just delete the stack, but the resource which were created would still persist. Then the third option is snapshot. I can delete stack, I can delete resources also, but to wherever applicable, like for your EC2 instance, for your RDS, for your elastic cache, all of that, before deleting, it will create a snapshot. So this is what your delete policy is all about. So you can define this condition under your stack policy section, and accordingly it will perform this task. Are we clear? Everyone? Yes? A quick check with all of you. Are we clear what your cloud formation is? So cloud formation, understand in a very simple term, it's a service which will allow you to create different AWS resources from one single dashboard by using templates. Now someone asked me, Prashant, how do I write this template? So these templates are to be written in a JSON format, but if you want the references, then you have a very good documentation from AWS, right? Where you have template references for different AWS services. You can leverage that and start understanding on how to write these templates. And not only this, I'll also give you some sample templates. Okay, I'll also give you some sample material which will help you write your templates in a better way. I'll have a book uploaded. I have a dedicated book. Okay. So here it is. I'll show you that book. So this is the book. Not here. So this is a book where you have all the details about this cloud formation template. So it is only purely for your cloud formation, close to 6,000 plus pages. Okay, where you have sample for every AWS services. You have sample code for every AWS service. How to write a JSON, how to write a YML for every AWS services is being discussed with example. Am I making sense? Everyone? So I'll have this book uploaded to the LMS portal. You can rely on this book material to practice your cloud formation. Okay. Okay, now very interesting question. If I have EC2 instance, S3 and all other resources already created, can I bring that as a part of my cloud formation? Is that the question Edureka guessed? You mean you want to bring your existing resources to your cloud formation? Yes, very much possible. For that, you have an option on AWS cloud formation called as importing existing resources. So you can import your existing resources to your cloud formation. So you can refer to this particular document. It will give you more insight. And here in the cloud formation options, you have an option called as with existing resources, import resources. So you need to follow this step by step. You need to define a template for it, and you can import your existing resources into your cloud formation. Are we clear? And okay, now something which is not there in curriculum, it also supports VPC. Yes, it does support VPC as well. Okay, now something which is not there in curriculum, stay with me for another 5 minutes. I'll show you one more part of this cloud formation, though it is not there as part of your curriculum. So the template which you write, you can see the template in a designer format. Now let me show you what your designer format looks like. This is what your designer format looks like. Basically, you can visualize what is that you are creating. You can visualize using the template. So right now, this is my template. So I have defined this template. So obviously the template is there. I can see this template in JSON format, YML format. But in addition to this, I can also visualize this. I can also visualize this. Am I making sense? So I can also create resources from here as well. I can directly, if I want to create something, right? I can directly create from here, and accordingly I can add resources. Let's say I want some RDS instance. So let's say DB instance. That's it. So this way you can directly add your resources as well from here. But you need to remember one thing, while you're directly adding, you still need to specify the components like mapping section, conditions, metadata. All of this you have to specify for your resources, right? And once you deploy, you can validate this template by clicking on validate, and it will tell you if the template is valid or not. So anything which you want to deploy, you can easily do that without any major challenges. Without any major challenges. Guys, am I making sense? So full-fledged architecture deployment is possible from here. So either you have your existing template, you can view that in designer, or if you don't have an existing template while creating also, right? You have an option called as create template in a designer, right? So you can directly create entire template in designer. You get a plain white chart. Okay. So on this one by one, whatever resource you want to create, you can define all of them here. Let's say I want an EC2 instance. So just drag and drop. I want a security group, drag and drop. So whatever I want to create, I can leverage this option, and I can visually create. I can visualize what I'm creating. I can integrate each other. Like I want this EC2 instance to be dependent on this cloud security group. So I can even define that. Are we clear, guys? This is not there in your curriculum, but just wanted to keep you informed of this. And this is called as creating template in a designer format. So this is again available under your CloudWatch cloud formation dashboard only. So you say create stack. While create stack, we saw template is ready. We uploaded our template. So if you don't want, you can say create template in designer, and you will land up on that designer page. Are we all clear? Any questions? Any questions, any doubts, any queries, something which are still not clear, then please do let me know. If not, I think yes, that's it from my side for our today's session. I hope you all enjoyed the session. I hope you all, understood the depth of this cloud formation service and AWS serverless computing. Yes, everyone. So CloudFormation is a very powerful tool. So you have these templates created. Like let's say for entire infrastructure, you can have some 5-10 templates created. Whenever you want similar kind of infrastructure to be deployed, just with one single template, get your job done. Maybe one time you'll need to spend some time developing this template, but once these templates are developed, you need not even worry. Everything is just a click away. Entire infrastructure deployment is just a click away. Now, if anyone has any question, please do let me know. No further question, then I think yes. Can we call it a day, everyone? All right. Then please do not forget to mark your feedbacks. I look forward to your feedback. I still see many of you guys have not marked your feedback. Humble request. Please do mark your feedbacks without fail. And if you enjoyed my session, feel free to mark it as an excellent, because excellent is the only positive feedback. Anything apart from excellent would be considered as a negative feedback. So I look forward to your feedbacks, and I'll see you all tomorrow. Till then, bye-bye. Take care. Wish you all a great evening, great day ahead, guys. Thank you so much for all your time and patience. Signing off for the day.